All right, today we're going to be solving polynomial equations. Now that maybe sounds familiar because you've done it before, right? We've solved a lot of quadratics, graph them, quadratic formula, complete the square. We had various methods. We're going to solve some bigger ones today, and I'm going to show you a couple methods to do that. So here's an example. Solve this cubic by graphing. Now those are nice when they say by graphing, because all we're going to do is go graph it, plug it into Desmos. And so I graphed this already just to save time. I'm going to zoom in on this graph a little bit. So when they say solve, we're looking for x-intercepts. I like to just set it equal to 0. And so if I set this equal to 0, like if it were on paper, I'm looking for the x-intercepts. Notice there's one, there's one, there's one. So my three solutions would be x equals 1, 3, and 4. Those are the three values that would solve that would make it equal 0. So that's really easy. If they say graph it, go graph it in Desmos, look for x-intercepts. Okay. Personally, if they show you stuff and doesn't have everything on the same side, I know the lesson's going to show you different ways. I would put everything on the same side, equal to 0, graph it in Desmos, look for x-intercepts. Okay, let's talk about sum or difference of cubes. This is just a special pattern. Whoa, that was kind of crazy. Sum or difference of cubes. These are a couple formulas. I don't expect you to memorize these necessarily. I would write these down though, so you've got them in your notes. So if you run into a sum or difference of cubes, you can factor them, okay? So sum a cubed plus b cubed, very general here, gives you this pattern. Difference, a cubed minus b cubed gives you this pattern. Notice these are very similar. The plus, there's a minus there, there's a minus here, a plus there. Very, very similar. So let me show you a couple examples. X cubed plus 125. Well, isn't that the same as x cubed, of course, plus 5 cubed? Now I'm just doing that to look at this. So my a is x, my b is 5. Now I can follow the pattern. So I've got x plus 5 times x squared minus 5x plus 25. Notice the 5 here. I wrote it in front instead of x5 because that looks weird. But there you go. Factored it. Okay, just following the pattern. How about this one? Wasn't this the same as 2x cubed? 2 cubed is 8 minus 1 cubed. So a is 2x, b is 1. Now we follow the pattern. So I got 2x minus 1. Now 2x squared, make sure you square the whole thing. That would be 4x squared, right? 2 squared and x squared. Plus 2x, just 2x times 1, plus 1. There we go. We just factored that guy, okay? So again, it takes a little practice, but write down those relationships. We can use that to solve some equations like this. 27x cubed minus 1 equals 0. What are the roots? So they basically want us to solve it. Well, isn't this the same as 3x cubed minus 1 cubed? So we're going to use that special pattern, all right? So that pattern, and again, you just wrote it down, I hope, so go look at it. So it's 3x minus 1. Then we got 9x squared, so a squared plus ab plus b. Now this thing, set it equal to 0 and solve. Well, we've already got a nice factor here. So 3x minus 1, if I set that equal to 0, x would be 1/3. So there's one of my answers, right? Just add 1, divide 3. So x equals 1/3. Now this one, let me break it down a little bit. I have a quadratic. Well, we know how to solve quadratics, don't we? We can use the quadratic formula. You can complete the square, I suppose. But let's use the quadratic formula for this one. Remember the quadratic formula? So x equals negative b plus or minus b squared minus 4ac all over 2a. Again, that's a good thing for you to have written down somewhere and be able to refer to. You use it a few times, you'll probably remember it. But let's plug things in. So a equals 9, b equals 3, c equals 1. So negative b, so that's negative 3. Plus or minus, let's go ahead and plug that in, b squared, so that's going to be 9, so 3 squared is 9, minus 4 times a, now a is 9 there, times c, which is 1, And we're going to divide that whole thing by 2a. So 2 times 9. Okay, let's simplify a little bit, see what we get. So square root, what do we got? 9 minus 4 times 9. 4 times 9 is 36. So 9 minus 36. 9 minus 36. What's that give us? 27? Negative 27? All over 18. Now we've got a negative under a radical. So that means we're going to be able to pull an I out, aren't we? And then pull an I out. That kind of sounded weird. Bring that I out from under the radical. So negative 3, let me just come down here. Plus or minus, now 27, so that would be 3 root 3. So 3I root 3 all over 18. Of course, now I can simplify a little. 3 divided by 18, 3 divided by 18. So negative 1 plus or minus I times square root of 3 all over 6. And then, of course, 1/3. So there are the 3 roots. Now these ones are imaginary, complex. That's a real root. Okay, one more problem. Let's go look at. Solve this. Now 4th degree. Woo. What are the roots? They just want us to solve it. Well, here's a form. It's called quadratic form. It feels a lot like a quadratic. There's 3 terms. This term's exponent is double this one. So here's a method I like to use. U substitution. Let u equal x squared. So basically whatever this guy is. So if that's the case, couldn't I write this as u squared plus 11u plus 18 equals 0. Now, let's look at this part. Because x squared squared is just x to the 4th. See how that works? That's why I can do this. Now, let's factor this. Or you can use quadratic or complete the square if you needed to, but this will factor. Factors of 18 add to 11. Hey, 2 and 9 will work. So u plus 2, u plus 9 equals 0. Of course, u could be negative 2 or u could be negative 9, but we're not solving for u, we're solving for x. So let's plug back in. So x squared plus 2 times x squared plus 9 equals 0. So now let's set these equal to 0 and solve. So x squared could equal negative 2. X squared could equal negative 9. Take the square root of both sides, right? You're going to get plus or minus. That didn't show up very good. Plus or minus. Now these are both imaginary. So x equals plus or minus I times square root of 2. Or it equals plus or minus 3I. So 4 complex solutions for that one. So quadratic form, you see something looks like this, a higher power, there's a good chance it's going to break down. You could do some substitution and factor it and then solve with some of our techniques. Alright, I hope that helps get you started in the lesson. Again, take some good notes, work things out. Have a great lesson.